Hi and welcome to Gaffy's Grinds. In this video, we are going to be looking at exam question from 2021 on the ordinary level exam paper. It was the titration question. It was question 2. So if you have your exam papers, it's a good idea to find that question. Go ahead and open it up, and you can work along with me. You will need a piece of paper to practice the answers on. You will need a calculator, and you will need your periodic table. Now, if you're not used to looking at the ordinary level papers, if you're a higher level student, then you will notice that many of the parts of this question are a good bit easier than the higher level questions. However, much of it is still relevant, and it's a good way I find of building up your confidence, particularly with the calculation parts, of building up your confidence to a stage where you're ready to then take on the higher level questions. So it's not a waste of your time by any means. I reckon 10 minutes for a higher level student, you should be able to find your way through this question. What I'm going to do is I'm going to get to pause the video. I'm going to get you to have a quick scan of the question, a quick read through the information. All right, so this is a pretty straightforward titration question. The reaction is between hydrochloric acid and sodium hydroxide. This is one of only two titrations that come up on the ordinary level exam. So we're going to skip over this piece of text for now because we probably are not going to need that information until later on when we're doing the calculation. We're going to jump straight into the question. So question 2, and it's part A we're looking at, A part 1. It says, identify the pieces of apparatus A and C shown on the right. So this is something that you do not get marks for in a higher level question. So at this stage, pause the video and write down what is A here and what is B. All right. So those are probably worth 3 marks is my guess. Yeah, I'm just looking at the marking scheme. 3 marks they'll work. So A, hopefully everybody knows, is a pipette. And B is a graduated cylinder or a measuring cylinder. So a graduated cylinder or measuring cylinder. So well done if you got both of those parts right. And just a quick reminder that it's really important that you guys pause the video and you do the practice yourself. Otherwise, if you're just relying on me, then you're never going to get to the stage where you can do it by yourself. All right, so 3 marks each. Well done. 6 out of the 50 marks so far should have been easy enough. Would A or B have been more suitable to accurately measure 25 centimeters cubed of the NaOH solution into the conical flask? Explain your answer. Okay, so this is A part 2. So first of all, choose A or B. Which one is more accurate? A or B? Okay, I'm hoping that you said A. Okay, and explain. Explain. Why is A more accurate? So pause the video and write in an answer. Why is A more accurate than B? All right, so I want you to think about the shape, and particularly when you're looking for reading the meniscus at the top of the level or the top of at the graduation mark as such, which one is graduated more accurately? Okay, so which one is graduated more accurately? Pause the video, write your answer. Okay, so in this case, A is more accurate because it's designed to hold exactly 25 centimeters cubed, and it's got a very narrow neck. Generally, the more narrow things are, pieces of glassware, the more accurate they're going to be. This is why we don't use beakers for measuring volumes of liquid, because they're really wide. And it's very difficult to be accurate with such a wide-necked piece of equipment. So things like volumetric flasks that have a very narrow neck, pipettes and burettes are very narrow, making them more accurate than anything that's less narrow. Sorry. So explain. A has a narrow neck. Has a narrow neck, and the narrow neck makes it a very accurate way of measuring out 25 centimeters cubed. So that's what you're saying there. You could say that a pipette is designed specifically for 25 cm cubed, whereas a graduated cylinder is not designed for exactly that volume. That's something else that you could have said. But the main reason we talk about here is it's got a narrower neck. All right, so on to the next bit. Part 3, what does it say here? How should the piece of apparatus you selected in 2 have been rinsed before using it to measure out the NaOH solution? So talk about how did you rinse this piece of equipment? Pause the video and write down your answer now. Okay, so hopefully what you said here is you said that it should have been rinsed first with deionized water. So rinse with deionized water. and then rinse with the solution it's going to contain. Now, in this case, it's going to contain, well, which one has been added to the conical flask? NaOH was added to the conical flask. So you could have said rinse with NaOH, or you could have said rinse with the solution it's going to contain. I'm going to say rinse with the solution it will contain, because that's a pretty stock answer that will always work. Solution it will contain. You could have also said rinse with NaOH, and that would have been correct as well. All right, so at this stage, let's just check where the marks were here. So we had 3 each for the first 2 bits. We had 3 for A here. We had 3 for the narrow neck for explaining the narrow neck. And then we had 3 each for this and 3 for that. So at this stage, part A was worth at 18 marks. They should have all been pretty easy to get. Moving on to part B. Okay, so part B. Name an indicator suitable for use in these titrations. Indicator. Okay, so the one indicator so pause the video and write down an indicator we could have used. All right, this is a strong acid, strong base titration, which means that either phenolphthalein or methyl orange will work here. Okay, so phenolphthalein or methyl orange. Methyl orange. Or you could have said phenolphthalein. Either of these will work. Phenolphthalein. Okay. All right, so hopefully you picked one of these. And then for part 2, it says state the color change observed at the end point. Okay, so if you didn't get this, here's a chance for you to choose one of these and write down the color change and get the next 6 marks. Pause the video, write down the color change. All right, so for the methyl orange is yellow in a base, and originally it will be in the conical flask with the sodium hydroxide. Okay, let's go back up here, and it should say a burette was used to add the HCl, so HCl in the burette, NaOH in the conical flask, which is the base. So that means our methyl orange is first with the base, so it's going to be yellow to red or pink. I'm going to say yellow to red. And the phenolphthalein is pink in a base, colorless in an acid. So that means it's going to be pink at the beginning to colorless at the end. So those are the color changes. Have to be in the correct order, guys. You have to start here. If you're using methyl orange, you have to say yellow to red. And if you're using phenolphthalein, you have to say pink to colorless. If you say colorless to pink, that's not going to be right. You're not going to get the marks there. Okay, so again, you got 3 for one of the indicator names and 3 each the color change. So before and after color. Okay, 3 and 3. So there's 9 marks for your section about the indicator. Let's look at part 3. What substances are present in the conical flask at the end point of the titration? Okay, well, what you have to do is you have to go and check the balanced equation, because at the end point, this and this are going to have reacted to make this and this. So these should be the substances present in your conical flask, or sorry, in your conical flask at the end point. So what you're going to do is at the end point, name these substances. Okay, now you would get away with just writing down the formulas, but just as a little bit of extra here, can you name those 2 substances for me now, please? All right, so hopefully what you said here was NaCl, was sodium chloride. This is salt. Okay, and H2O, which was water. Of course, the methyl orange will still be there as well, so you could have said that. Methyl orange. Okay, so these are the substances present in the flask at the end. Sodium chloride, water, methyl orange. And you're getting any 2 there, 2 by 3. So long as you had 2 of those, you're going to get 3 marks each. Well done. All right, so it says here, on average, 23 centimeters cubed of 0.3 molar solution were required to neutralize the 25 cm cube portions of NaOH solution. Calculate in moles per liter the concentration of the NaOH solution used. Okay, so this is where we get into our calculations bit. And the calculations for this are definitely going to be easier than the calculations in your higher level question, but they still require a little bit of thought. All right, so what I always advise my students to do is begin by first of all, reading carefully here, part C again, have another read of it and see exactly what they're asking you to do. So pause the video, work your way through very slowly through the text, and then go back up here and read this again very slowly and just looking for all the pieces of information that they've given you. So make sure we've paused the video and done that, read very carefully through. Okay, the next stage is, I think the next step here is for us to write out our balanced equation. Okay, so let's go part C here and write out your balanced equation. Do that now, please. Okay, so your balanced equation is HCl plus NaOH, and that reacts to give NaCl plus H2O. And what we want to know is what is the relationship between the HCl and the NaOH here. So I always get my students to draw the two arrows like this. And what we want to know on those arrows is the molarity and the number of liters used in each titration. Okay, so pause the video and write down that information now. All right, what you should have here now is for the HCl, we know that it's a 0.3 molar solution of HCl. So this is the concentration, the solution whose concentration we know, 0.3 molar. And we know we use 23 centimeters cubed of that per titration. So in liters, so we're converting to liters, showed you how to do this in the previous couple of videos. So I'm not going through that again, but that's 0.023 liters. All right, for the NaOH then, we don't know the concentration because that's what we're trying to find, calculate the concentration. So this is a question mark molar. And what we know is that we had to use 25 centimeters cubed portions. So how many liters is that? Well, again, I'm not showing you how to do this. I've showed you in the previous videos. If you're still struggling with this, you got to go back and learn how to do that. And don't come back here until you know. 0.025 liters. Okay, so we got to work with these now to find the unknown. So planning this out, pause the video and plan out what are the units that will go in between. So using our unit analysis that we've looked at before, how do we plan this out? Pause the video, do that now, please. Okay, so obviously we're starting with moles of HCl per liter, and we're going to moles of HCl. So we need to cancel the liters. Think about how we would do that. Then we're comparing the moles of HCl that reacted with moles of NaOH. So we want to find out from moles of HCl, how many moles of NaOH did that react with? And then we want to turn that moles of NaOH. We want to find out, well, what's the molarity, the moles per liter of NaOH. So moles of NaOH per liter. So hopefully that's the plan that you have in mind here. Okay, so now that we know we have our plan, let's pause the video and work our way through that now. Okay, so hopefully we're starting with 0.3 moles of HCl per liter. Of course, that's what molar means, moles per liter. Again, I'm assuming you know this because you've watched the previous videos. If you haven't watched them, it's not a good place to start. Go back in the playlist here. All right, we know that we need liters to cancel here. So we're going to times this by a number of liters. Now, how many liters should we use? Well, it's how many liters we use per titration, 0.023 liters. So there's my liters cancel out, and that's going to give me a number of moles of HCl. And that's going to get me to this part of my reaction. All right, so what you should have had here is 0.3 times 0.023. And that's going to give me 6.9 by 10 to the minus 3 moles. 6.9 by 10 to the minus 3 moles of HCl. All right, so I'm going to say that that's part 1. And then part 2 we're going to do on the next line. So this was part 1. Part 2 is to go from moles of HCl to moles of NaOH. Of course, we need moles of HCl to cancel then. Let's go ahead and write that down. We had 6.9 times 10 to the minus 3 moles of HCl. And we need those to cancel. So using our unit analysis, how can we make those cancel? Well, we need a conversion factor that has moles of HCl on the bottom. That will allow them to be cancelled. And then we've got moles of, what are we going to? We're trying to go to moles of NaOH. So that's on the top here, moles of NaOH. And of course, where do we find out for how many moles of NaOH do we have for how many moles of HCl? Well, that's this balanced equation. This is a 1 to 1 ratio. So up here, 1 to 1 ratio. So that means I have 1 mole of NaOH for every 1 mole of HCl, which just means that my number of moles doesn't change. I have 6.9 times 10 to the minus 3 moles of NaOH. So that's got me to step part 2 of my reaction or my plan here. And now I need to go to part 3. I need to change it to moles per liter. So I currently have moles of NaOH. And I want it to be moles of NaOH per liter. Well, if I want it to be moles of NaOH per liter, I need to put per liter on the bottom. Okay, and then how many liters of NaOH did I have? Well, here it was here, 0.025. Okay, all right, so now that I have that, we're going to do 6.9 by 10 to the minus 3 divided by 0.025 or over 0.025, and that's giving me equals 0.276 moles per liter, and that's NaOH. Okay, and if you got this far, well done. That's super. That's the correct answer. That was worth 9 marks of the calculation. So give yourself 9 marks for that, and well done. Okay, now that's very similar to the early bits of a titration question on a higher level paper. Okay, you might have something else to do after that, but it's pretty much the same up to there. Now, it's actually unusual that an ordinary level question would have any extra bits after that, but this one does. This one has a part D. Okay, it says the student then added exactly 23 centimeters cubed of the 0.3 molar HCl to another 25 centimeter cube portion of the NaOH solution. So exactly what they've done, they added 23 on average. This time they've done it again, but without the indicator. So what they're trying to do here, and you should maybe notice from your junior cert titration, is they are trying to produce a sample of salt that's not dyed by the indicator. Okay, because in a normal titration, this titration, they would have produced salt and H2O, but of course there's leftover indicator in here, leftover methyl orange, which is red at the end, and that's going to dye your salt red. So if you wanted a pure sample of the salt, do it without the indicator at the same amount that you've calculated without the indicator. You should have salt and water in here that's not dyed by the indicator. What you could then do, as you said, it says, how could the student have obtained a pure dry sample of sodium chloride using a piece of equipment in apparatus C? Okay, so again, we're talking D part I. Okay, so first of all, what is apparatus C? That's what I want you to write down. C equals, what is the name of this? Okay, so hopefully you know that this here is called an evaporating basin. So C is an evaporating basin. It didn't ask for that, but that's just a bit of revision from junior cert. An evaporating basin. How could the student have obtained a pure dry sample of the sodium chloride? Remember, at the end, they've got a conical flask that's got water and sodium chloride dissolved. How could they take that solution and get pure salt from it? Pause the video and write that down now. Okay, so hopefully you would realize they could take your conical flask and pour it in here. Okay, pour the contents in here and then heat this up and evaporate off the water. So they evaporate off the water and leave behind the dry salt at the end. Now, the reason why you're not familiar with this, guys, on a leaving cert, on the higher level papers, is because this titration here, sodium chloride and HCl, is only ordinary level. This is not on the higher level course, which kind of means that you may not have come across this step before, okay, unless you remember it from junior cert. But describing what you would do here, this is what we would say. We would evaporate the water. That's simply all we really have to do. Evaporate the water using the in the evaporating basin, and then once it's dry, once it's all gone, you have the dry salt. So evaporate the water in the evaporating basin. In the basin. You could do this on a windowsill slowly, or you could put it on a hot plate and heat it up and get it done quickly. All right, let's move on to the last bit here. Calculate the mass of NaCl produced if 0.0069 moles of NaCl were formed in the neutralization reaction. Okay, so look, it's telling you you produce 0.0069, and you have to tell me how many grams that is. All right, so this is pretty straightforward, I hope. We covered something very like this in the earlier videos, So what I want you to do is pause the video and write down a plan for what conversion or what calculation do you have to do here, please. All right, so I'm hoping that what you said was you have to go from moles of NaCl, because it told you we have this many moles of NaCl were formed, and you have to calculate the mass of NaCl. So moles of NaCl to grams of NaCl. So pause the video now and do this calculation, find the grams of NaCl. All right, again, if you don't know how to do this, again, I advise you to go back to the very start of this playlist and watch the conversions that we did there, and that should give you the understanding to be able to do this here. All right, so we know we have 0.0069 moles of NaCl. And we want to convert, we want moles of NaCl to be gone. Okay, so how can we do that? How do we get rid of moles of NaCl? We times it by a conversion factor that has moles of NaCl down here. Okay, so that means we can cancel it because it's in the denominator, and here it's in the numerator, denominator. So moles of NaCl over moles of NaCl cancels out to give us 1. And then on the top of this conversion factor, we have grams of NaCl. So the last thing then is the number relationship here. For 1 mole of NaCl, how many grams would that be? So you're going to need your periodic table for this. And hopefully, if you haven't already paused the video and worked this whole thing out, that you can pause and finish this off before me now. All right, so what I'm going to do is I am using the numbers for sodium. I am using 23 as the mass. And for chlorine, I am using 35.5 because that's the number that's on the log tables. Your periodic table might have a different number. It might be rounded to 36 or 35. I'm going to use 35.5, which gives me a molar mass of 58.5 grams. Okay, so once I have that, then it's very easy to work out how many grams. All right, so your correct answer here is equal to 0.404 grams of NaCl. And that is the correct answer. It's actually 0.04365 is what I'm getting here if you write down all the numbers on the calculator, or you could round it to 404, and that's NaCl. All right, guys, so that is the 2021 question. And again, we're going to be trying to move quicker and quicker as we go through these papers. Hopefully that was pretty straightforward and you were able to do all the bits. And you're starting to see, okay, the ordinary level questions are pretty easy, but they're still teaching us the skills we need to be able to do, the basic skills to be able to do the higher level ones. So that's it, guys. I shall see you in the next one when we do the 2020 question.